Welcome back to Aurora Tech Channel. Today, I will review the Creality Ender 3 V3 Plus. It's a pumped-up version of the Ender 3 V3, which I reviewed a few months ago. The Ender 3 V3 is the new top-of-the-line machine from the Ender series. Now, the Ender series also has the Ender 3 V3 SE, which is the cheapest, being a sub-$200 printer, and it's a basic Marlin-based bedslinger. There's also the Ender 3 V3 KE, which has a very similar appearance aside from adding a linear rail to the X-axis and running Clipper firmware instead of Marlin, so the printer costs around $250. So, the Ender 3 V3 and the Ender 3 V3 Plus are top of the line with Clipper firmware and CoreXZ kinematics and cost $330 to $430. Let's take a look at what we can get from this Ender 3 V3 Plus. The CoreXZ kinematic flipped a CoreXY frame and made it work as the X and Z axis, so you won't see any lead screws on the machine. The gantry is a one-piece die-cast aluminum. The X and Z axis on this V3 Plus are using thicker 10mm linear rods compared to the V3, and the Y axis is using thicker dual 12mm linear rods compared to the 10mm ones on the V3. The Y axis is using dual stepper motors to prevent step skipping when printing at high speeds. The extruder is very similar to the one on the new flagship Creality K1C. The nozzle is a tri-metal quick-swap nozzle, and it can print abrasive filaments like nylon carbon fiber right out of the box. The claimed maximum print speed is 600 mm per second, with the maximum acceleration of 20,000 mm per second squared, similar to the K1C. The maximum nozzle temperature is 300 degrees Celsius, and the max bed temperature is 100 degrees Celsius. The bed leveling uses 4 strain gauges placed underneath the bed to sense the pressure from the nozzle. The Z offset is automatically set. For the cooling system, it has 2 high RPM fans, one installed at the back of the print head and one inside the front cover. The filament holder is placed at the right side of the machine, with a support stand that works as a clamp to prevent the filament from tangling. The firmware runs Clipper. The 4.3-inch touchscreen, as well as the screen UI, is the same as the one on the K1C, so it's more like a bedslinger version of the K1C with a larger print volume. I would like to thank Creality for sending us this machine to review and for sponsoring today's video. And with that, let's get started. The packaging of this machine is in line with other Creality machines. The top layer includes 2 support rods, a spool holder and anti-tangle stand, a power cord, the LCD screen, and some tools. The second layer is the CoreXZ gantry. The bottom layer is the base and a sample 200-gram roll of filament. I just put the gantry on the base and secured 2 screws at the front. We also need to flip it over as there are 2 more screws at the bottom. Do the same to both sides. Then, mount the support rods to support this relatively tall gantry. Connect the stepper motor cables. The print head cable needs 1 zip tie as a strength relief, and there's also a cover to make it look nicer. Mount the touchscreen at the front and connect the ribbon cable. Mount the spool holder and the anti-tangle stand, and finally, flip the power voltage to match your local voltage, and now the machine is ready to use. Once it turns on, it's very similar to other new generation Creality printers. Select the language, then agree to whatever it says, and select your 2.4 GHz Wi-Fi network and enter your password. Then, it will show an IP address, but you don't have to remember as Creality Print can find it over the network. Select the time zone, and for Creality Cloud, I will skip it and just print over my local network. Then it will start a self-test, which requires 15 minutes. It will test the hot end, heated bed, fan, input shaping, and bed leveling. You don't have to do anything, so just wait for it to finish. After that, a firmware update screen pops up, so I will just let it update to the latest firmware. After a few minutes, the machine restarts, and it needs to calibrate input shaping and bed leveling again. I think it would be better for Creality to rearrange the sequence of the setup process. After connecting to the network, it should check for firmware updates first before doing self-testing, so users don't have to waste an extra 10 minutes recalibrating the exact same things. Okay, we can now load some filament and start our first print. I will start with the preloaded 14-minute fast benchy G-code. I will let it print a few more layers and reach the top speed, and then do a sound test. The sound meter is around 6 inches away from the table. It stays at around the mid-50s, but when there are rapid movements, it will reach the high 50s. For an unenclosed fastbed slinger, I would consider anything less than 60 decibels to be acceptable. The print finished in 14 minutes. The layer height is 0.25mm, so the layer lines look more obvious and there is some ringing, but the overall surface quality is not too bad considering the speed. There are some cooling issues in these areas, but the front is slightly better, with only some minor cooling issues. I will then slice another one using Creality print with the standard 0.2mm layer height profile. This print took 29 minutes, which is still pretty fast. The layer lines and surface quality have some improvements, and the front and bottom are looking good. Let's put them together to compare. The 29-minute one looks better in terms of layer lines, surface quality, and cooling. It's a pretty decent print for a less than 30-minute benchy. Then, I will print some of our benchmark models, starting with the number slider. I used the new Creality Print V5 to slice this print, and as you can see, instead of using the Cura engine, Creality joined Prusa Slicer, Bamboo Studio, and Orca Slicer, as the slicers to prepare for their new K2 Plus with multiple filament printing, so it's a good time to switch to the Prusa or Bamboo Slicer family. This slicer can find the printer on my network, and I will just send the job over Wi-Fi. It took 2 hours and 14 minutes to finish, which is slightly faster than the 2.5-hour average printing time of most of the latest generation clipper machines. The top has some stringing, but the bottom looks nice. As we can clearly see gaps between the tiles, it can move freely. Up next, I will print the honeycomb box to test the retraction and stringing of the extruder. There is some stringing on the flat surface, but the honeycomb patterns on the side seem alright, so I will just let it finish. The print finished in 2 hours and 4 minutes, which is faster than the average 2.5 hours among new generation clipper printers. The top surface is not super clean, but the sides look pretty nice, and all the patterns can be printed without breaking. Let's take a look at the same model printed by different printers. The Ender 3 V3 Plus is surprisingly better than the V3, as I'm using their new slicer, which is based on Prusa and Bamboo Slicer. In terms of stringing, the Prusa XL and the BambuLab X1 Carbon are slightly better, but the Ender 3 V3 Plus is still better than other printers. Then, I will test the tolerance by printing a simple geometric model to see if the parts can fit with each other. This print normally takes 2.5 to 3 hours, but it finished in less than 2 hours this time. For the square, it can clear from 0.225 all the way to 0.075. It's a bit tight for 0.05, but I can still almost push it in, so it's almost perfect. For the cylinder, it can also clear up to 0.075, and it's similar to the square, but as this model was printed 30% faster than normal, there's a lot of ghosting on the text. Next, I will test the surface quality by printing a decorative model, the Robo Alpaca from Prusa. The print finishes in 4 hours and 21 minutes, which is in line with the normal printing time between 4 hours and 15 minutes to 4 hours and 45 minutes for most new generation printers. As a bed slinger, the print quality is average, and I can see quite a lot of ringing on the surface. When compared to the Ender 3 V3, the V3 Plus is slightly faster, but the surface quality of the V3, which is a smaller bed slinger, is better. When compared to the larger bed slinger, the Neptune 4 Max, the V3 Plus is faster and has better surface quality. It seems the size of the bed is an important factor when comparing surface quality. Among all bed slingers, the Prusa MK4 has the best surface quality, but the printing time is also the slowest, even with the new input shaper firmware. When compared to some CoreXZ printers, the printing time of the K1C is almost the same, but it has a much better surface quality. The result is similar when compared to the BambuLab P1P, which is also a CoreXZ. The print speed is also similar, but the P1P has better surface quality. Then, I will print a large trash can to max out the 300mm Z height. The first layer is not too bad. There are a few spots that seem to be squeezed too low, but it should have no impact on the print at all. The lower part of the model looks fine, but let's see how the print quality decreases as it gets taller. It's about 70% done, and you can see the ringing is much more obvious now. I actually ran out of the red filament at around 80%, so I just grabbed another roll of blue to resume the print. Okay, the print finished in 9 hours and 14 minutes. Like all other bed slingers, when printing a tall model like this, the lower half of the print looks okay, but as the print gets taller, the momentum from the bed creates more ringing. However, the bottom stuck perfectly to the textured PEI sheet with zero warping, and the inside of the trash can also looks alright. I will print one more PETG model, the stack tire pen holder. When I tested the Ender 3 V3, the strong extruder was able to push PETG at 18 mm cubed per second, so I will try the same on this V3 Plus. As you can see, I set the volumetric speed to 18 mm³ per second, resulting in a print speed of over 200 mm per second, which is super fast for PETG. The first layer is already pretty fast, and it speeds up like printing PLA after the first layer. The print finishes in 2 hours and 50 minutes, whereas the average speed is usually 3.5 to 4 hours. The surface is nice, the details are clear, and there is a tiny bit of stringing, which is normal when printing PETG. The bottom and the overhanging parts are not too bad, as I set the cooling to 20 to 40% when printing PETG. The inside of the model also has minimal stringing. Let's try some different materials. As this is an open frame printer, I will apply some glue to the bed and try to print an ABS crate. The bottom sticks really well to the glue, and there's no warping so far. This print also needs the extruder to print a tiny bit of filament and retract right away. It seems the extruder can handle it very well with just a tiny bit of stringing. The print finished in 3 hours and 40 minutes, and there is still some warping. It seems it's unavoidable when printing ABS on an open frame printer unless the model is small. The patterns on the crate are good, as the cooling is often printing ABS to prevent the plastic from cooling too quickly and causing cracking. Some overhanging areas may need some simple cleanup, and the bottom has a little stringing, but overall it's still a usable ABS part from an open frame printer. Then, I will print a TPU wallet. The volumetric speed is set to 5 mm³ per second, so the actual printing speed will be limited to 62.5 mm per second. The print finished in 50 minutes. The extrusion was pretty good, and there were no issues when feeding the flexible filament through the PTFE tube. There was also no under extrusion, and the bottom and side were printed nicely. As the maximum nozzle temperature is 300 degrees Celsius, and the bed can heat up to 100 degrees Celsius, it should still be able to print some modified polycarbonate. So, I will print a cable holder using the Prusa PC blend filament. As I printed this model with 50% infill, it took more than 1.5 hours to finish. The part is rigid, but the surface is not as clean as when printing PLA. I see some strange patterns on the surface that I didn't see on other materials, but as we print polycarbonate, mainly for how rigid it is, it's still a good functional part. The nozzle also has a hardened steel tip, so it can print abrasive filaments. I will print a cover with nylon carbon fiber, as I recently upgraded one of my old CR Tennis Pro V2s to a Sprite Extruder Pro. My cable management is quite messy, and I need something to cover it up. I will use the Creality Space Pi dryer and dry the nylon at 70 degrees Celsius for 4 hours before starting this print. the print finished in 55 minutes, and as the nylon is quite dry, the surface looks pretty good and the back looks even nicer. It looks pretty good on the CR10S Pro V2 and covers all my messy cables. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The gantry is a one-piece die-cast aluminum, so there are no screws and nothing will loosen over time. 2. The motion system uses 10mm linear rods on the X and Z axis and 12mm rods on the Y axis to support the print bed. So, when the printer is printing at high speeds, it's still pretty sturdy. 3. The leveling system is the same as the one on the K1C, using 4 strain gauges underneath the bed to sense pressure from the nozzle. This new bed leveling system is better than using a single BL Touch, CR Touch, or inductive sensor like on most other printers. Although you need to manually move the nozzle up slightly to print a PLA sheet first layer, which uses almost the entire bed, the results are good. They're not perfect, but they're sufficient for prints of any size. 4. The extruder is strong. Generally, I don't expect to be able to print PETG at the maximum flow rate of 18mm per second, which is equal to 225mm per second. I normally see some kind of under-extrusion on other machines when the print speed of PETG is over 150mm per second. 5. The dual-part cooling fans are strong. The machine can print as fast as most CoreXZ printers with an auxiliary fan, and I didn't notice any major cooling issues even when printing at a higher than average speed. 6. The machine can handle most materials at a faster than average speed. I can print ABS without issues, and it also comes with a hardened steel nozzle, so I can print nylon carbon fiber right out of the box. If the filament is dry enough, it's almost as easy to print as PLA on this machine. Now for the cons. 1. The input shaping is not working as well as I expected. The service quality is not too bad, and it's at least better than some larger bed slingers, but with the all-linear rail motion system, a sturdy gantry, and a well-supported print bed, I expected the surface quality to be better. 2. The filament holder, heated bed cable, and hot end cable are all on one side, making the right side of the machine a bit crowded. The filament support stand is used to prevent the filament from coming off the spool and causing tangles. This part is required as it needs to move to the top to trigger the limit switches when homing. It still works, but it's just too crowded to have everything on one side. 3. The CoreXZ design eliminates the need for lead screws, which could potentially prevent issues like layer bending and Z-axis wobbling caused by bent, misaligned, worn out, or poorly shaped lead screws. However, in my experience, the majority of printers using lead screws don't encounter these issues. Z-axis layer bending issues are often due to factors like over-tightened or loosened palm wheels rather than the lead screws themselves. While the automatic belt tension adjustment in the CoreXZ setup is a good thing, the ability to rapidly move the Z-axis for faster Z-hopping provides some advantages, but does not significantly enhance print speed. Overall, I don't see the CoreXZ kinematic as a game changer compared to traditional bed slingers using linear rods or rails. 4. The slicer has a bunch of glitches. First, after you change slicing parameters, the slicer won't recognize that changes have been made. It won't allow you to slice the model again unless you move the model around and then move it back. I wasn't able to find my custom filament settings. I discovered that the user configuration is sometimes placed at the top and sometimes at the bottom, seemingly at random. Next, when I try to print a single layer model, the slicer doesn't show the estimated time. However, it works normally for other prints. Additionally, the printer profiles in the V5 slicer are minimal. It includes the K1 series and Ender 3 series, but it doesn't include the V3+. So I just used the V3 profile and changed the print volume, assuming everything else would be pretty much the same. When I tried the latest V4.38 release, it also didn't include the V3+. This can be very confusing for new buyers who can't find their new Creality printer on either of the two Creality slicers. Finally, there are also some minor translation glitches in titles, as well as other issues I haven't discovered yet. Creality could allocate more resources to identifying and fixing these glitches before releasing a new slicer. In conclusion, the Ender 3 V3 Plus has solid hardware, even stronger than the V3. The thicker linear rod motion system, the one-piece die-cast aluminum gantry with 2 extra support rods, the strong extruder, all make this printer one of the best in terms of hardware. However, the firmware, especially the input shaping, still needs improvement. I expect it to get better after a few firmware updates, just like the K1 series, but we'll have to wait and see. Switching the slicer to the same family as Prusa and Bambu slicers is a good move, as they generally do better than Cura and are a good platform for handling multiple color printing. However, I expect the Creality will need a few more updates to address most of the glitches in their slicer. I would say the Ender 3 V3 and V3 Plus have the best hardware among all new Creality bed slingers. This machine has a lot of potential with its interesting CoreXZ kinematics and open source firmware. However, as of today, I can only see the K1 series and the Ender 3 V3 KE firmware on their GitHub, and not the V3 series yet. I hope Creality will release that soon, and let software experts in the 3D printing community contribute to their firmware. If you're interested in this machine, I included the link to it as well as to my website auroratechchannel.com, which monitors the prices of over 150 popular 3D printers, all in the description. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.